So thank you for coming. Very happy to be here. Thanks, Signify, for inviting me over and over to speak here. And I'm finally here. And I'm going to talk about building IDEs. And no worries, I'm not going to dive into like compiler internals. In case you wanted that, then I'm sorry. But in case you didn't, in case you wanted something fun and high level, this is going to be closer to that. So yeah, let's get to it. First of all, why would you build an IDE? First of all, for fun. Maybe you have a proprietary DSL at work, or just something you made for yourself for open source or whatever. Or maybe you just want a cool topic and you just happen to have done this kind of thing before. So I'm in like all of these categories actually, but let's focus on the last one. There are many options for building IDEs. I just mentioned a couple here. For example, how we can, like, what kind of UI we can give our IDE. Maybe we don't even need a UI. Maybe we just like send bytes to, through your telephone or something. You can write your own front end if you want to. I didn't want to. You can use Monaco, which is the component that, for example, VS Code is using for its editor, and that's actually what we are going to use. Or you can try to integrate with an existing editor like VS Code, IntelliJ, NeoVim, Emacs, or anything else. For analysis, so basically the meat of your IDE, you can go like with many levels of how well you want it to work. Basically, you can just have syntax highlighting, which is going to be very easy. You can do it in any language, in basically any environment. You can do some kind of best effort analysis, like you can try to understand what's a keyword, what's a definition, what's a reference to that definition, or if these two symbols that have the same name are actually the same thing. So I think GitHub does kind of things like this, like it can tell you if your Scala, let's say you're referring to a variable name, like if it's the definition of the reference. But they are not actually analyzing your code semantically, they're just doing like basic analysis. Or you can do like full-blown analysis, so then you may need to integrate with some kind of compiler, some kind of other tools that are meant to be used for your language when you develop tools for the language. So in my case, I'm going to use Monaco and communicate with a compiler, which is going to be sort of built into the server of analysis. I'm not using the real name for it yet, just give me a couple slides. But there's a huge problem in whatever you decide to do, like whether you write your own front end or integrate with something that exists. Anytime you want to add support for a new editor with this kind of analysis with your language, you need to integrate with its extension API or whatever kind of like plugin mechanism or just language support, like new languages in the editor. And they all have different APIs for that. And not only that, they also have sometimes some special requirements. Like if you have an IntelliJ plugin, you should run on the JVM. If you have a VS Code plugin, it probably has to run in Node.js. And if you cannot fulfill these requirements, you have to cross process boundaries, just shell out to something or use whatever kind of connection to some remote process. And that's pretty bad. And like it's okay if you have one editor and one language, but it's okay. Yeah, this is why I didn't zoom in on the slides. But it's actually you cannot see that. Anyway, it says like this is not manageable. It just doesn't work very well when you want to add more editors, more languages. It's just you're going to have an exploding amount of combinations that you need to support, integrate every language tool with every editor. That's just not going to scale. There must be a better way to do this, and there is a way. There is something called the language server protocol, which is essentially this common language that language tools or language servers, this is what they are called here, can use to communicate back and forth with your editors. The arrows actually should be like both directions. I missed that. So this exists, it's the language server protocol, and it basically describes a bunch of operations that you can perform on a text document, on a workspace. You can have the server which deals with like your language-specific stuff. Ask the client for some information like configuration, maybe like how long should the lines be when I do formatting, or you can display some kind of notification, some window, all sorts of stuff. And the clients, so like the editors, can ask the server like, hey, where's the definition of the thing that I'm at, like the cursor is at, or how do I rename this symbol to that symbol? So in like a quick summary, what does the usage of the LSP work look like? First, we have to initialize the connection. This is started on the client side. We send an initialize request, and we get an initialize response. This is used to exchange information, for example, about what the client can do, like what kind of capabilities it has. Does it have windows? Does it have alerts? Does it have any kind of feedback mechanism? Or does it have completions and stuff like that? And the server can say the same, like, do I support completions? If not, for example, the client may just not show this option at all. Like in like a context menu, it will just not show you the way, like options to like go to definition if you don't have that ability. So once you have initialized, you can start sending requests and notifications. Notifications such as the client has opened the file, it has changed the contents of the file, or it just closed the file. These three are actually very important because the server either needs to handle like none of them or all of them, and it's basically, if you have well, the server needs to access these files somehow, the files in your editor, and it's not always possible to read them from disk because maybe the file is not yet saved. Like maybe you don't save on every keystroke. You don't want to do that, most likely. So in order to still be able to do some kind of analysis on unsaved files, you need to listen to these events. For example, the change will tell you the text of the file or what changed in the file. We'll get there. But yeah, you listen to these notifications on both sides. You also listen to requests. So the client can ask, for example, the server, like, where's the definition of what I'm looking at? Or what are the errors and warnings and like diagnostics in my document? Or the server can ask the client, hey, what's your length, line length? Or like, what's the base URL for this HTTP client that you're using? And yeah, that just works like both ways. This is very important to notice that, to realize that it is a bidirectional communication. It's not just like a client servers. These are just names, kind of. And of course, this is again trend. But that's an example request and response for text document definition. So I'm at a position in the document, I just want to go to definition. So the client should send this is using JSON RPC protocol. The client has to send the URI of the file, so which file we have opened, and the position, which is I think 0 indexed on both sides, but don't quote me on that. All the technical details are in the spec, it's just I didn't implement the spec. So we get the position, the file, and the response is supposed to be the start and the end of where the definition is. And it can be a different file, which is why we also have to send the URI back. In this case, it's the same file, but you get the idea. So now with this information, we should be able to implement this kind of server. And I'll start with the client. So this is the IDE using Monaco for our language. It's called Badline. And it's a very simple language. We just have three constructs. We have variables defined with let. We have show, which is supposed to like print a concatenation of these variables at the current state. We have inc. Oh yeah, sure. Thanks. We have inc, which is a way to increment a numeric variable. This could be type checked, and perhaps we have a type checker implemented already. And we have show again. Well, this is just these three things. So let, show, and inc. And currently, this is just plain text. I cannot do anything here. So let's try to connect to a language server. So Monaco is, in itself, is just a library. It doesn't do any kind of connection with a language server. But there is a library called Monaco Language Client, which implements a language client for Monaco. It basically kind of, at the moment, makes it behave like VS Code, which has ups and downs. And it's not super straightforward to configure, so I'm not doing it live, but if you want to take a look, that's going to be included. Most importantly, I'm creating a WebSocket connection, and that's going to call like my local machine. And this WebSocket connection is going to be used to exchange information with the server. So that's one possible way that you can talk to a language server. The standard sort of way is to use standard input-output, but I cannot do that from a browser. I need to use WebSockets. And you can also use like TCP and other environments. However, my server is implemented with standard input-output, so I'm also using this thing called LSP, the WebSocket proxy, which will forward the WebSocket connections from this port to my process, however I launch it. So let's try to implement that process. I'm using a library called Langosteen, which is a very fresh library for Scala 3, written by someone who's in this room, actually, and not me. Thankfully, not me. And yeah, I just have some boilerplate, but there's nothing yet. Like, this is not working at all. If I try to run this, actually, I'm just going to get a bunch of errors in my console. Don't even look at them. It's just like there's nothing going on. Like, there's no language server. So let's start a server. Langosteen provides this module called Langosteen app, and this includes this Langosteen app type. If you're familiar with IO app, it's kind of like this, except instead of giving the library an IO, you give it a resource with an LSP builder. So let's provide one, just like it's a very simple builder. So I'll just do resource pure, LSP builder, create of IO. And now maybe I can run this. I'm going to reload. This is going to create a new connection, a new WebSocket connection. And we should be able to see the messages. So the client has sent the initialize request, but the server did not see it because there is no, well, it did not respond because I didn't handle the initialize method. So we need to add a handler for initialize. And yeah, I'm going to actually move to another place. I'm going to implement this inside the server make function. It's going to be very useful later. So I'm going to call server make right here. And yeah, let's just use this builder. I'm going to handle the request to initialize. And I'm going to get this this request handler is going to be this function from the input to some kind of IO. I'm going to just use IO unit and see what the compiler can tell me about the type. I very much recommend this kind of method, especially if you have a fast compiler, which we all know that Scala is. So I need to return this very specific and very understandable type. Thanks again, the compiler, for desugaring this type. But I happen to know that I can go to this definition, and I see the types right here. So we have, in our input, we have this initialize params thing. It's going to be some kind of case class, which is, by the way, deprecated, okay. Actually, no, it's not deprecated. The deprecated thing is on one of its fields. This is a bug, yeah. Yeah, I already filed that like 2 years ago. And we need to return initialize result. So let's do like IO pure. I don't know what I need to pass, so I'm just going to stub it out. Let's look at this in first. This gives me both the parameters of the request and also a communication channel, something that I can use to send a notification or a request back to the client. I'm not sure if by spec you are able or allowed to talk to the client sort of asynchronously, but this kind of design kind of points you to just talk to the client while handling a request. Maybe that's a possible feature. Who knows, right? But we're going to use the parameters. So actually here I don't even care. I'm just going to specify what capabilities the server has. So in my initialize result, I'll say capabilities. It's going to be this. First of all, we need to sort of tell the client how we are going to talk about the text documents or the files. And that's going to be this text document sync. And I want full sync. for my fellow Assassin's Creed players, this is the goal. Not sure if anyone still plays that, but this means that whenever something changes in the editor will send me the entire file, not just like what changed. That's too difficult. I don't want to do that in the talk. And I think that's an option, or like an opt, which is a fancy new type over a or no. So that's number one. So this just tells the client to send me updates of the file. We should be able to run the server now and like get some kind of useful stuff out of it. So initialize was sent. We sent a response back. Then the client tells us, okay, I've initialized, and I've opened this file. This is a notification, so if I don't handle it, then don't handle it. It's okay. I didn't, so it's silent, but it's still not doing much, and I cannot like do any kind of analysis here. The end goal for this talk will be to implement go to definition, but yeah, let's try to do it. So I'll add a handler for the request text document definition. I just want to say like how nicely typed the library is, because I can say I'm handling the text document definition request, and I know exactly what the input type is going to be. Well, the compiler knows. Maybe I need to look it up, but I cannot like say I cannot do like references, which is like find references to this variable, and expect this input type to be go to like definition parameters. It's just not going to type check. So it's really nice to do this. I think in other languages, some tooling is more like stringly typed, so they don't have this kind of cool type safety. Anyway, you have to go to definition request, and that's going to be the params. That's going to have, for example, the document and the position, right? So first, I'll need to read this document. I actually have a slide for this. Hold on. First, we need to read this document, this file, parse it, and find out where we are in the document, right? Like what I'm looking at. And then like find the full name of that, and try to find the first let matching that name. So, and for that let, we'll just return its whole range. So I'm going to try to parse that. Let me just remember. No, I still first need to load the file. So how do I get the file text, right? I don't have any source of that information because I didn't listen to the did change notification. The client is not sending me the text of the file at the moment. So I'll need to add some extra steps before I can actually properly handle this request. So I'm going to listen to the did open notification. And that's going to have the text document with the text and the URI. And I'm going to put this into an in-memory cache. First I need to define that. And I think I have that implemented already, so document cache. Make, and as the key I'm going to use document URI, which is the type from Augustine. And I'm going to map on this. Get rid of this, and I pass this cache to my server. Okay, I should be able to put the thing into the cache. If anything is unclear, you can ask questions now, because we have some time. But hopefully it will all be clear by the end. So I'll just put this into the cache. And on close, I'm going to do the opposite. I'm going to remove this from memory. And this one is going to be pretty tricky. I need to handle the notification on when the file is changed. It's going to be tricky because of types, because these types are not defined in like handwritten Scala. They're generated from, I think, a JSON description. So some types, like union types, are not very well represented, and we can see this in this type right here, which is that the one? Yeah, it's like a union of S0 and S1. So not very well descriptive names, but we should be still fine. So did change. Actually, we can try to see what kind of data we get here. Let me try to load, and I'll change the document. Not sure if you can see it. Let me try to copy this. So we are getting the URI of the document, a version, so that you can maybe compare which the change request is newer, notification. And we get the content changes as an array in that file. And because I did full sync, I know for a fact that I'm only going to get full content changes, but S0 and S1, one of these is for partial changes, so I need to kind of ignore it. So
question, how often do the content changes come through? Like if you type a character, is that an event?
It's
or is
on every character type.
Ah, okay.
So hopefully, by spec. So I'm going to take these params and the changes, and I'm going to call the best method in the world, which is called traverse. And I'm going to try and pattern match on this. And I think it's S0. So that's the incremental one. I'm just going to ignore it and return an IO stub. And for the other one, I think we just get text. And I'm going to... I was hoping for GitHub Copilot, but I actually did turn off Wi-Fi, so no. Hold on.
A lot of postman time.
Okay, I can actually do it. And that's going to be in params text document URI and text. Like, hopefully we'll just get one of these changes. Let's just stick to this assumption. And that should be it. So now I have this cache, and there's also this mystical thing called text documents. That's just like a more high-level API on top of document cache, which I'm going to use to read the file at this URI. Let me just make an instance of this. Text documents, cached. The implementation is actually going to try to get the thing from the cache first, but if it's not there, for example, if it's a file that's closed at the moment, it's going to read it from disk. That's not going to work with a browser client, but we actually don't need it to work because we always will have the thing in the cache. The file is always open. So let me try to use that in our definition request. So docs, I'm going to get this file at the URI. Text document URI. And that's an IO document. If it fails, I kind of don't care. Let's just fail. But yeah, that's going to be a document. The document has some content, which is a string. As I mentioned, I'll need to parse this and kind of analyze it. Fortunately, the parser is already written. So I'm just going to parse it like that. Hold on, I do think I did it in a simpler way back then. Just steal this. Okay, yeah, I just did two options. So if this fails, we'll do something. If it succeeds, we'll have a parsed value. And we'll also see what happens. And yeah, let's try to get the compiler to tell us what the types are. Just return some bizarre type. And yeah, it's not a string. It's supposed to be another IO of an opt of definition or vector of definition links. I'm going to go with the simpler one, the single definition. It's hopefully just one definition. So in the case of none, I think I can just return an empty option, opt empty. Actually, this should probably be just a map, so no I/O. But if it did parse, then I think I can analyze this. Find, yeah. So we are at a position. This is not the reference. This is so this is not the definition. This is the reference. So I need to find a reference that matches this position, which I think is this. And we're going to use the parameter with the position, and I'm going to convert it from the LSP model of langoustine to my internal representation of the position, which I think is 2 model. That's just a very straightforward, okay, methods wasn't very helpful here, but that's just a very straightforward conversion between 2 similar types. So I have that definition, that reference. If it doesn't exist, I think we just want to default to empty again. If it does exist, that's the reference. We'll need to find the definition matching the symbol. This is going to be a name in some kind of wrapper. So we go to the parsed file again and look for the definition of that name. That's another option because, of course, everything can fail. Maybe I'm using a variable that wasn't defined before, so we have nothing to go to. So I have an option of a name, required of nothing. That's not what I would expect to see, but okay. So I can match again. By the way, if you want to get rid of these kind of ugly pattern matches and options and like mix it in with effects, in this case, probably a flat map would do, but also I encourage everyone who isn't familiar with those to get to learn about monad transformers. Very cool stuff. Just don't use them in production code because it's ugly. So choose your level of ugly, like this kind of ugly or difficult to understand ugly. So again, we have an option. If it's a none, you already know what we're going to do. So yeah, this kind of pattern is, maybe we can refactor it after we write it. And if we have a sum, oops, perhaps now we can finally return something, right? So that's going to be a name. Hold on, find definition. Don't tell me I have to go to the parser again, to the file. Okay, I'm going to cheat again and look at what I did before. And then I'll show you something cool, like actually cool. Find the yeah, I'll just steal this, you know. How about this? Okay, we're moving towards it. Great, now everything broke. I can blame this definitely on significant indentation in some way. Okay, you know what? I'm just going to steal this, the whole thing. It's not worth it. This... It's going to be the same thing though. Just maybe in better syntax. No! Option, opt, maybe you can convert. Yes, okay. Now hopefully the whole thing just works and we can move on to the cool stuff. So let's wait for it to initialize, and it almost works, I'm sure. Oh, there's one more thing I didn't do. Maybe someone spotted the mistake, but I handled the request without actually saying that I can handle it. I need to add it to my capabilities. So I'll say that I have a definition provider, and I think it's an optional boolean, so something like this. And now maybe? Yes, so it works. And not only does it work here, it'll actually work in VS Code itself, because I do have an extension as well, which is using a language client, and that also happens to work here, with no extra code on the client, right? It's the same implementation on the server side, which is kind of the whole thing, the whole reason why we are using LSP. So that's one cool thing. But another cool thing I wanted to show, with Langoustine, you don't only get a library, you also get a tool, an amazing tool which is called the Langoustine Tracer. So I can wrap my launch script of my LSP server with the langoustine tracer, and now that's going to launch something. Okay. Where's the rest of the console? Yeah, it's going to launch a server with this very pretty UI, which I can use to debug these requests and responses. So this is my initialized request. I can see the response for it. I can see the initialized notification. Now we can make some changes, and we can prove that we did get a couple. Okay, maybe one did change request. Maybe it's not actually doing it on every keystroke. But yeah, we can see what happens. We got a did open, we got a did change, and if I go to definition, let's actually do it on a working file. There's our request, and there's the response. So I think that's pretty cool. How are we on time? Okay, an hour. So yeah, we could do this all day, but this is about as much as I was ready to do. Hopefully this is interesting, and if you ever have a need to build something similar, you will know to maybe trust in LSP and implement just one side of the equation instead of both over and over. And yeah, this is all I had. The slides and the code will be posted later on the event, and if you want to get in touch or yeah, just get in touch and ask some questions or give some feedback, all the contact links are in the link tree. So thank you again, and hope you had a nice time.